Today we are going to solve HackerRank's problem, absolute permutation. So in this video, first we will go through the problem statement, then we will try to understand the solution, and then we will have a quick walkthrough of the code sample that I have written to solve this problem in Java programming language. So let's go through the problem statement first. It says, we define P to be a permutation of first n natural numbers in the range 1 to n, and let POS at I denote the value at position I in the permutation P using 1-based indexing. P is considered to be an absolute permutation if this condition satisfies or holds true for every I in the array. And this condition is basically you take the value at I index minus index itself, and then it should be equal to k, and k will be provided to you. And you always need to consider the absolute value, so you ignore any negative number, basically negative sign you need to drop. So for example, what it is saying, n is 4, k is 2, and then your array becomes 1 2 3 4, and using 1-based indexing create a permutation where every element is true for considering this criteria. So it can be rearranged to 3 4 1 2 so that all the absolute difference is equal to k. So if you see at index 1, if you subtract position, that is 3, minus index itself, it is 2. And then if you do 4 minus 2, then it is 2 again. And if you do 1 minus 3, that becomes minus 2, and you need to take the absolute value. So at the end it becomes finally 2. And then similarly for 2 and 4, at index 4 you get minus 2 as the value, but absolute value is 2 only, and so it means this becomes true for all the elements in the array now. So it means it is an answer. You just need to return 3 4 1 2 as your answer. But if you can't find any answer after trying all the permutations, then you need to return minus 1. So you will be given this function in the code below where you need to submit the solution, and you can simply write your code. You will be given n as input number and k as another input number. So n is your upper bound of natural numbers to consider, and k is your absolute difference between each element's value and its index. So let's try to solve the problem. To solve the problem, one helpful test case for me was where n is 100 and k is equal to 2. And if you take a look at the result, you'll be able to find out what exactly author is trying to ask us. So in this case, let's consider indexes like this. So basically 1 2 3 4 5 6 7 8 9 and so on, and then values 3 4 1 2 7 8 5 6 11 12 9 10. So basically what will happen, just to hold k equal to 2 true, the value at you need to find the value. So first the value at index 1 is 3, value at index 4 is 2, so the difference is still 2, and now the difference of these values at index 3 is again absolute 2, and then difference at index 4 and its value is 2 again. And now let's consider this thing again. So if you consider index 5 6 7 8, you see the value 7. So basically here it becomes a pattern. If you pick the value of index 1 here, and then you add 2k to it, then you will have 3 plus 2 into 2, that becomes 7, and you will get the value at index 5. And similarly you will get the value at index 6. So basically you pick the value at index 2, that is 4, and you add 2k to it, so you add basically 4 to it. So 2k is 4, and you get 8, and then you pick value at index 3, and then you add 4 to it, you get 5 here, and then you pick the value at 2 and you get 6 after adding 4 to it. And now you need to compute next 4 values. So basically, to compute next 4 values, you pick the value at 5 index and then you add 4 to it, you get 11. You pick the value at index 6, you add 4 to it, you get 12. So you will keep on repeating this pattern and you will get your answer. So in this case, this is what it is following, basically what I just explained to you. So at index 1, you do like this, you calculate the value, and it is holding true for values at index 1, 2, 3 and 4, and this is the pattern. So if you have observed it, what you are saying, if k is given to 2, you need to just calculate your pattern for first 2k numbers. It means you multiply k by 2 and then compute the value of that many indices first, and then you keep on repeating it based on what I just explained here while going through the result. So let's go through the code to better understand what I'm trying to say here. So first of all, in this code, I'm just initializing input list and adding -1 to it. So this is basically adding it at index 0, and we need to add it in case if k is 0, you don't have to do anything. You simply return you simply have to return the input list that we are going to form later on in this logic, in this method. So if k is not equal to 0 and you can divide n by 2 and you find modulus of that by k, and that modulus is not giving you 0, then it means there's no solution for this problem. Because you consider, let's say if n's value is 100, you divide it by 2, you get 50, and you do 50 modulus 2, then you don't get equal to 0. So it means you can proceed with your solution. There will be some permutation that exists for that input combination, and you need to calculate that later on. But if you don't get if you get equal to if you don't get equal to 0, then in that case you just need to you can find the answer. You just need to return the list with -1 as its element, because there is no answer possible for that. So in this solution, what we are doing, we are first initializing we are first initializing 2k places, as I mentioned. So if k's value is 2, then you need to calculate first 4 places, and that is what we are doing in this for loop, and we are achieving this POS I minus I equal to k here, and you can see how we are doing it. So I'm calculating the value at index 1 first, and then to index 1 I'm adding substitute is basically the value of k at the moment. And why I'm using this local variable substitute, because I'm going to modify that substitute in the logic so that it kind of reverses itself. So I'll walk you through now. So in the input list at index 1, I first add 1 plus 2, and it becomes 3 as the value at index 1, and then at index 2 it becomes value as 4, and 4 is basically the value at index 2, that is 4 at the moment. It becomes equal to 2k. So k here is 2 in our example that we considered, and then if it becomes k, I kind of reverses it. So basically I negates it and multiply it by 2, so that the value of substitute becomes -2. So when index is 3, then what it will do, it will calculate 3 minus 2 here, because substitute's value is -2, and it will give you a result as 1. And if you consider, if you are seeing this example here, this is how it is calculating it based on this logic in the for loop that is starting at line number 58 until 64. So it will calculate these 4 values. Now we know if we just keep on using the 4 values like this and keep on repeating it in another in the logic going forward, you will probably get your answer. Not probably, you will definitely get your answer there. So I'm repeating it like this. So what this algorithm is saying, from line number 68 until line number 77, that you are starting at index 2k plus 1. So basically you are starting at here. If you see what I have selected in the solution here, so you are starting at index 5, and then you are calculating the value. So if k's value is 0 in first place, then it will hold true, and it will just keep on inputting the values in the index at, so basically it will go through this way. It will keep on creating this array if k is 0 without doing any permutations or any changes in the array, so that you can just return input list as it is, because you don't have to do anything in that case. But if k is not 0, then you need to just write the algorithm just to get previous 2k elements, and then need to multiply, or sorry, need to add 2k number to the previous element's value, and then you get the next element in the list. So as I mentioned, you can calculate next 4 in this example by using the value from last 4 calculations, and then you can calculate these next 4 based on the values of previously calculated 4 elements. So if you follow that, you will have your array populated, and then once your array is populated, if you have reached until this point, you finally remove the value at index 0. So basically, if you remember, you added -1 just to start with at index 0. So if you have gone that far, it means you have got a permutation that exists for this solution, for this problem statement, and then you can remove the last. In the end, you can remove the number at index 0, and you just need to return the list as your answer. So I think we covered the problem statement and the solution for it, and you can see that the solution is actually taking here, it is just taking 2k steps here, and then again it is going from 5 until n here. So overall, this is solving the problem in a linear time. I hope you liked the video, and thanks for watching. We'll see you in the next one. Thanks.